Welcome in. Here's an interesting example. So this one relates to vectors. So if you're studying grade 12, for example, vectors or physics, okay, and you're working with kind of static environments, so things that are not necessarily moving, I really like this example, okay, to be able to illustrate your understanding of vectors. So if you have, here's someone, I guess, just hanging almost like if you can think of, pull-ups, okay, as you're kind of hanging around, while this one, the arms are kind of stretched out there. You're going to be holding on to something. So in here, I guess you have these two, it's almost like kind of handles that are being attached to a particular beam. So here's the actual beam. Now, obviously, you don't want the beam to collapse. So you're hopefully, okay, as you're hanging and you're not necessarily lifting yourself, it says you're in a dead hang position. So dead hang means you're not really moving. You're just kind of hanging from there. So we want to be able to find out what these forces are in here, and notice that they're kind of transferred. So there's your handle, and then your handle has two parts. So the transferring is not a big deal because we can find out what the actual force is on the handle and then cut it in half because it is transferred at each particular point. And then it will tell us, what the actual beam has to be able to hold up in there. And that would have happened on the right-hand side as well. So over here, you would have had the same kind of forces, assuming that everything is spread out equally. Okay, so how do you handle this kind of situation? Well, if you're thinking about forces, then what you would be able to do is this person has a weight, and the weight is always the force which is pulling us down. So if I was breaking this down in here, so what would happen? This is going to have, a force down. So let me draw a force straight down, and that is 750 newtons, right? That's what we have coming from the weight of this person. Now that particular person, okay, will have a tension in their arms. So as you're going through here, so there's a tension, right? Okay, in this direction. And now the opposite, okay, so there's also a tension, okay, in the opposite direction, which is going in this direction, which is exactly what we want to find. So within here, as long as we find these 2 points, we can certainly find out what that tension is, okay, so this one and this one. And then we can find out what's happening over here because it has to be in equilibrium. And because of the equilibrium, so that means the summation has to be equal to 0. So the opposite force there, which is being held up by that beam, is going to be spread across. So if you're thinking about this, so at this particular point, you have a force which is in this direction, but it is being spread, okay, over here. And it is spread over here. So it's going to be kind of two forces, one in this, okay, and then here's the other one, and it's going to be basically the same direction as this one that you see over here, except it's going to be half of that. So that's going to be our goal. So I'm going to start from this point over here. So I have a force that we have to support of this particular person. Now it is being spread over, so notice this is at 45 degrees, so this is going to be one of them, and then here is the other one at 45, and the 45 is coming because that's what the angle that it's telling me, okay, so I guess that this person is hanging at that particular 45 degree angle, so that's what I have. And if you're thinking about that, right, so within here, so this is going to be creating a triangle. So this is a 90-degree triangle. So if this is 45, then this is 45 as well. That's how I'm getting that. So I have one force, and then I have that force which is being spread over into these two components. So that's the y component. So obviously, so within here, so this, okay, is going to go in the opposite direction to be able to equal that off. So this is going to be 750 newtons, okay, in this direction, and that's going to be spread out in half between the two. So that's a very interesting question in here. So 750 spread into two components, into these two components that we have here. okay, across one arm and the other arm. So that's going to be 750 divided by 2. So that's going to be, I guess, 375. So that's going to be the actual components which are spread over. So that's 375, okay, within there. That's the amount of force that is spread out. But please keep in mind that that is, times 2, and that's in the y direction, so that's upwards. Okay, so we have to find out what this force is. So what we're having, I'm going to just take one of them. So what I have is, let's say this is 375. 375 newtons. I'm going to try and find out that red, okay, which is this one right here. And that's going to be spread over on that side. So I don't know what that is, but I do know what this angle is, right? So as you can see there, the actual red, so that force, okay, is the hypotenuse of this. So if this is 375, right, it would have been, let's call this kind of the hypotenuse right there that I have, and the opposite one is going to be on the other side. So what is that going to be equal to? Well, what we would have is we would have h, right? And then that would have been, I guess, cos or even sine. So cos of 45, and that is supposed to be equal to 375 newtons. Okay, well, that's not a problem. Can find out exactly, well, at least in its magnitude over here, what that is, because I know the angle. So that's going to be 375 divided by, so, well, cos of 45 is actually 1 over the square root of 2, but I guess I can just put it in as cos 45. So that's going to be approximately 530 newtons. Okay, I'm just rounding it over here. That's the force which is spread. And if you've ever hung, like if you're hanging, okay, in this way, the tension is going to be bigger because you are at an angle than it is just simply straight, okay, where your arms are straight up there. And if you've ever done any pull-ups, that's why the wide pull-ups are so much harder, because of the fact that your tension across, okay, those particular arms is a little bit more than it is if you're just doing straight ones up, where you're just going vertically straight in. Now here we're not doing any pull-ups, but we're doing a dead hang, okay, within. Okay, so we have 530, so that means this is also spread on the other side. So now we know what that particular force is. Okay, so we have, so this is 530 here and then 530 here. Now, you might say, well, it looks like if you do that, you also have a horizontal. That's correct. You do have a horizontal one, but because you're spreading the forces across 2, so as you're going in this direction, right, and as you're going in this direction, so the y component, so the 750 newtons, which is down, is being canceled off, right, by these two vertical ones, which are 375 newtons, 375 newtons. And then the horizontal ones, you indeed would have horizontal in this direction and then horizontal in this direction, but these two cancel each other off, right? That's why this person's not moving left or right, okay? It's just the vertical that you have in there. So it is the actual body that, like as you're hanging in this direction, okay, so you would have those tensions pointing out in there, so that means they're also canceling out over here. So that's what we have, and that's being spread out, okay, all the way over there. So you have 530 newtons, which is present, so that's this right here now, the tension which is across coming over here. So that means that's the tension, okay, coming across over here, but it is, notice, split into 2. So 530 divided into 2 would have been 265. So those FBs, that FB is equal to 265, and you have 1 over here, and then it's split in half, right? Because of the handle which is attached on both sides. So I'm assuming that it is split in half over there, and that's what the beam is going to have to support. Okay. In order to, for this to be static. So that's 265 newtons. Okay, so notice that particular FB, and it is 45 degrees, northwest, for example, if you wanted to give this a direction. So 45 west. That's what you would have over here. And that's actually the problem solved. And that is using equilibriums and a nice kind of a tension example with regards to how forces are passed through, okay, your actual arms as you're hanging by those handles. So that is it, okay? So for this example, I hope it makes sense to you. You can give it a try, okay? Give it a shot. And if you like the video, give it a thumbs up, and we will see you in future examples, okay? Take care of yourself. Bye-bye.